time, so it's on, I think. System audio, I don't want that. Right, so it's on. Okay, so I tried to change my setup. Let's see if this works. So straight lines, right? Okay, let's go to the first exercise. What do you want? You want first exercise. Wait, area of triangle. Isn't this straight lines? Why are properties of triangles over here? I mean, of course, they are made from straight lines, that's why. But okay. Oh, so you are also given some advanced properties like Euler line. Okay, cool. So that's nice. Euler line. That's actually like a like an Olympiad level stuff. But if it's there, it's there. I'm gonna use that as well. So choose a frame of reference and convenient points. Right. Okay, let's start in chapter exercise 1. So our first question is proof that the points negative a, negative b, 0, 0, a, b, a square, b square are coordinate. Well, they are. As you can see, all of them have the same slope. Like negative a, negative b and 0, 0, these have slope 1. 0, 0, a, b, those also have slope 1. A, b, a square, sorry, 0, 0 and a squared, ab, that also has slope 1. So yeah, all of them are definitely just collinear. Second, ABC are points in the XY plane such that, so you have been given A and B, and AC is 3 times BC. Then prove that there are infinite number of such triangles. So this is the second question, right? So what do you have? You have x minus 1 squared plus y minus 2 squared equal to, that's actually like, that will be AC square. That's going to be 9 times of BC squared. So 9 times of, or we could say, so this is the eraser, I think. So what is 9 times of BC square? That's like basically 3 BC square. What am I saying? So it's going to be what? Like 3. Now let's just use 9. 9 into x minus 5 squared plus y minus 6 squared. Okay, we don't want this. Okay, cool. And let's just expand this. So this will be x squared minus 2x plus 1 plus y squared minus 4y plus 4 equal to, yeah, what was I doing? 9 times of this guy. So 9 times of x squared minus 10x plus 25. Right? I think this is not the best way to do it. Instead, let's use this as, this will be like 3x minus 15 square plus 3y minus 18 square. Yeah, that's a better way to do it, I think. So that means that goes over here and it becomes 2x minus 16, subtract, wait, minus 40 in that case. Right, when you subtract, and when you add, this will be 4x minus 16. Okay, and similarly, this goes over there, this becomes plus 2y minus 20 into 4y. Oh no, it should be minus 16 over there. So minus 16, this is 4y minus 20, this is equal to 0. Cool. And you can get these 2 and 4's out, so this will be x minus 7 into x minus 4 plus y minus 8 into y minus what, 5 equal to 0. So it's just a circle. It's a circle with diametrical points 7, 4 and 8, 5. Or wait, no, this is not right. With diametrical points 7, 8 and 4, 5, which means the center should be 11 upon 2 and 13 upon 2. If you expand this and then write it as a proper circle, then you will see that this is the center. Okay, cool. Okay, so this is like infinite scrolling or something. So let's go to the third one. Third is let a, b and c be these values, then Okay, these are 3 points. Is that AB equal to BC? Oh, okay. Then the number of distinct values of x is fine. AB equal to BC. So AB squared equal to BC squared. So using Pythagoras theorem, 5 square plus 4 square, so this will be 4 square, equal to, what's BC squared? X minus 1 square plus 8 minus 3, I think, so 5 square. This cancels. That means x minus 1 is plus or minus 4. So x is 1 plus minus 4. There are two such values. Number of distinct values is 2. Okay, this won't work. So I'm just going to write it over here. So the answer is 2. Okay. Yeah. Okay, fourth. If the point, what is this point? 2 comma y divides the line segment joining these 2 points internally in the ratio m is to n. And the value of y is. Let's try to graph this internally. So it should be on the line first of all. Wait, if it's on the line, then y must be 3, because if I try to graph this, it's just 4 comma 3, 6 comma 3, right? So this is the line, so it's y equal to 3. Then yeah, like y is just 3, no doubt. Why did they give us m is to n ratio? Well, I mean, m and n are variables anyway. Or did they want us to find in terms of m and n? Who knows? Next. If the vertex of a parallelogram are this, then the fourth vertex, so 3 vertices are given and you want to find the fourth vertex. I hope these are in clockwise or anti-clockwise, I mean in the same sense, right? So one after another and stuff like that. So the first guy, okay, let's just say A. What's this fourth question? Wait, this is not the fourth question, it's the, which question is this? Fifth question. So the first point is a plus b, comma a minus b. The second point is 2a plus b, comma 2a minus b. Then that means that the vector going from a to b, which will be a b vector, that will be a, comma a. Wait, okay, that is weird, but that's how it is. And c is a minus b, a minus b, comma a plus b. D we don't know, let's let that be x comma y. So what, CD vector? Yeah, CD vector, that will be x minus a plus b, comma y minus a minus b. Right, now let's try to draw this. A, B, this thing will be C, this thing will be D. So CD vector is going like this, AB vector is going like this. These are opposite of each other. That means CD vector is negative of AB vector. Negative of AB vector is just negative and negative A. That means x equal to a minus b, negative a, and y equal to a plus b, negative a. Is that correct? That means x equal to negative b, y equal to b. That should be negative b, comma b is the answer. Man, I can't write on this. That's a problem. But hopefully this will work. Hopefully. So that's fifth. Let's go to the sixth one. The ratio in which the line divides the line segment joining these points. Okay, line segment joining these points, that will be y minus 3 upon x minus 1 equal to 7 minus 3 is 4 upon what? 2 minus 1 is 1. So y minus 3 equal to 4x minus 4. That is the line segment, or you can say y equal to 4x minus 1. That is basically the line joining these 2 points. Okay, and you also have y equal to negative 3x plus 9 as another line which cuts this line. Where does it cut it? That will be 7x equal to 10. So x equal to 10 upon 7. That's the intersection point. Okay, what is y in that case? y is 4x minus 7, which is 40 upon 7 minus 1, which is 33 upon 7. So the intersection point is 10 upon 7 comma 33 upon 7, right? And this is in some ratio, right? This is the point, and it's basically like doing this thing. Oh, you know what? There was an even better way of doing this. You know, this line cuts it like that. So just find the perpendicular distances, the signed perpendicular distances of these points, the ends on this line, and take the ratio of those two and make it negate it basically. That will give you the internal ratio stuff. Yeah, because similar triangles, right? Okay, but now we have got this. And what was this point? Uh, 1 comma 3 and 2 comma 7. So what's this vector going to be? This vector will be 3 comma 7, 3 upon 7, and 33 minus 21, which is 12 upon 7. And what will this vector be? This will be 2 minus 10 upon 7, which is 14 minus 10. Yeah, that's like 4 upon 7, I think. And what's this? 7 minus 33 upon 7, which is 49 minus 33 upon 7. That is 16 upon 7. So this thing's like 3 times of 1 upon 7 and 4 upon 7, and this thing is 4 times of 1 upon 7 and what, like 4 upon 7. So it's in ratio 3 is to 4. This is 3 times something, this is 4 times something. So there we go. M is to n is 3 is to 4. What do you want exactly? The ratio, of course, which is 3 is to 4. Okay, that was 6th. Let's go to 7th. The coordinates of midpoints of the side AB, BC, and CA of a triangle. I mean, okay, won't this get hard to navigate through? But hopefully not, man. Hopefully not. 7th is the coordinates of midpoints of the side AB, BC, CA of a triangle are given. Coordinates of its vertex is, oh, so you know that the midpoints, the median triangle, that also has its centroid as the centroid of the actual triangle, the original triangle. So what is the centroid? It's just, well, it's like 1 plus 0 plus 2, it's 3. 3 upon 3 is 1. Then 2, okay, that's 0. So 1 comma 0 is the centroid. And you already know what the midpoint is, right? What's the midpoint of CA? That is 2 comma negative 1, right? Wait, we don't want CA, we want BC because we want the side opposite to A. So BC is 0 comma negative 1. So this is 1 comma 0, this is 0 comma negative 1, right? This is our midpoint, this is our centroid, and you got the vertex. You know this is going to be in 2 is to 1 ratio, right? Yes. Call this thing x comma y. So what is this vector? This should be negative 1. 1 comma 0 and 0 comma negative 1, I think. Yes, this was negative 1. What's this vector? This vector is just 1 comma 1. What's this complete vector going to be? It's going to be 3 times of that, which is 3 comma 3. So x comma y is just 3 comma 3 plus this original position. So x comma y, this is 3 comma 2. There we go. That's the thing. So you got the vertex. Okay, and what do you want? Okay, next question. 8. The ends of the base of an isosceles triangle are this and this, and the equation of one of the sides is given, and the orthocenter of the triangle is just graph this. What's this? Question number 7. This is question number 8. What was I doing? The ends of the base of an isosceles triangle are 2 comma 0, 0 comma 1. I'm not graphing this, but drawing. So yeah, these 2 points, one of the sides is x equal to 2. Oh, look at that. This guy has x equal to 2. This guy doesn't have x equal to 2. That means the third vertex, that also should have x equal to 2 because it's one of the sides. That means it's 2 comma something, call this something as y. Then the orthocenter of the triangle is orthocenter of this triangle. Well, you can find what y is, I think, because these two must be the same. Actually, first of all, just find what this midpoint is. It's just what's this? It's 1 comma 1 by 2. Okay, fine. Then there's a perpendicular bisector going through it and stuff. Now let's just use the fact that these two are the same. That will be, oh, this length is just y, right? Because yeah. And what's this length? It's square root of 2 squared, which is 4, plus y minus 1 squared. So what that means is y squared equal to y squared minus 2y plus 1 plus 4. This cancels. So 2y equal to 5, y equal to 5 upon 2. Cool. So this guy, this is just going to be 5 upon 2. Cool. Now you got that. What do you want? You want wait, where was it? Orthocenter of this guy. So I already know what this line is. What is this line really? It's just y minus 1 upon 2, right? Upon x minus 1. Yes. Equal to 5 by 2 minus 1 upon 2 is just 4 upon 2. Is this for real? Yeah, it looks correct to me. Okay, fine. So it's 4 upon 2, which is 2. 2 upon, oh yeah, it's just 2, basically. That means 2y minus 1 equal to 4x minus 4. Yeah. 2y plus 3 plus 4 minus plus 3. So 2y plus 3 equal to 4x. That's our first line. And we need another line. Maybe this line. Right. Yeah, I mean, like we need another altitude. Okay. So what's the slope of this guy? This guy just has slope of 5 by 2 upon, oh no, this is not going well because it has slope of infinity and stuff. Oh wait, but if this has slope infinity, right, it's just x equal to something. Yeah, then this guy, it should have slope 0 because it's y equals, yeah, x equal to something, that's the vertical line, y equal to something, it's a horizontal line. So this guy must have slope being equal to 0. There's only one way for that to happen, that this guy must be 1 and something. But at least you now know what this line is. This line is just y equal to 1. Yes. So now we know that the orthocenter also passes through this line. So putting that into this, you just have 2 plus 3 equal to 4x, x equal to 5 upon 4, but y is equal to 1. So our basic point, that orthocenter, that should be 5 upon 4 comma 1. This is our answer. Okay, let's go to 9th. Oh wait, why did this? Okay, maybe I should put this to not sleep mode or something. Okay, let's go to the next question. Yes. What was I doing? Next question. So the next question is, let's actually move this a little bit. Okay, just bear with me. Okay, now it's good. What was the next question? The triangle ABC, A is, we don't want the answers. A is 1 by 10, circumcenter is given, orthocenter is given, coordinates of its midpoint of the side opposite A is. Oh, so circumcenter, orthocenter given, that means you can find what centroid is. So if I draw some kind of generic triangle. For example, the orthocenter, that will be somewhere over there. The centroid, that will be, oh, that's also like the midpoint. Oh, this is not supposed to be the orthocenter, that will be somewhere over here. Midpoint stuff. Okay, so this is the centroid, and so consider somewhere over there, I think. Right, so you know how the story goes, right? That the median triangle has the circumcenter as its orthocenter, and then you shrink down all the sides, all the parts of a triangle. That means you also shrink down the length between the orthocenter and the centroid. So this is half of what it would be originally. So this is 2:1 ratio. Okay. So we know what this guy is, what this guy is. So we can figure out what this guy is. It's going to be 2 times the circumcenter. Circumcenter is -1/3 and 2/3. Okay. Plus 1 times of the orthocenter, which is 11/3, 4/3, and that upon 3. So what's, wait, is this for real? It's 11/3 and 4/3. Yes, that's how it is. So yeah, of course, that's how it should be. So 11/3 minus 2/3 is 9/3. So 9/3 and 8 minus, it's not minus, wait, it's 4 plus 4 is 8/3. That's bad. That's really bad. But that's what it is. Okay. That upon 3, like this. And this is going to be equal to 1, 8/9. That is the centroid. Yes. So you know the centroid, you know the vertex A, you can figure out what the midpoint should be. So this is 1:2 ratio, right? You know what this guy is like. A, this thing is G. You just want this midpoint. Yes. So what's this vector? It's going from G to A. A is 1, 10. This vector is just 0, 10 minus 8/9 of all things. Why? I don't understand this. Okay, 10 minus 8/9. Just going to leave it like that. That's what this thing is. And you just want to figure out what this vector is, which is just -1/2 of that. So that will be 0, -5 plus 4/5. No, not 5, it's 9. So you know what that vector is. Just add this vector to the centroid, which we already know. So it's 1, -5 plus, okay, 8 plus 4 is 12. 12/9. So it's 1, -5 plus 4/3. 4/3 plus -5, so -15 plus 4 is -11. -11/3. Who knows if that's correct or not, but we'll go with it. Okay. Next. Where was I? The coordinates of the points A, B, C are -4, 0, 0, 2, and -3, 2 respectively. Fine. The point of intersection of the line which bisects the angle CAB internally and the line joining C to the middle point of AB. Let's just draw this first of all. So what question is this? This is 10th. Okay. The coordinates of the point ABC are given. Let's draw this. -4, 0 is something like this. 0, 2. That's going to be like this. And -3, 2. That is like, okay. Look, wait a second. What's this? Like -3, 2. This thing is also 2, and yeah, there is no symmetry and stuff. Okay, what was going on? the point of intersection of the line, but this is like ABC, right? ABC, which bisects the angle CAB, so like this, and the line joining C to the middle point of AB. Okay, so this point. You need to find that point. Let's start with the angle bisector first. What's the slope of these two? You already know what A is, so you just need to find the slope of this and we'll be done. What's the slope of these two? C and A. So C and A. C is minus 3 comma 2. A is negative 4 comma. Just actually write this down. Negative 3 comma 2. A is negative 4 comma 0. And B is 0 comma 2. So this guy's slope, that will be 2 upon 1, right? This guy's slope, that will be 2 upon 4, which is 1 by 2. Wait. What is this? 2 upon 1, 1 by 2, that's just reciprocals. That means, oh, I get it. These two angles, they are complementary. They add up to 90 degrees. But you know that this angle, these two angles, this angle and this angle. But you know that this angle, that's just the average of these added up. I mean, okay, average of these two angles. And they add up to 90 degrees. So it's just 45. There we go. This slope is 1. You know what this point is? We are basically done for this guy. So it's y upon x plus 4 equal to 1. So y equal to x plus 4. That is this line. What about this line? What is the midpoint of A and B? That would be negative 2 comma 1, I think. And you know what C is? So y minus 1 upon x plus 2, I think. That should be 2 minus 1 is 1 upon negative 3, negative of negative 2, which is negative 1. And that means y minus 1 plus x plus 2 equal to 0. So x plus y, this is getting laggy for some reason, plus 1 equal to 0. Yeah, this is getting laggy. Maybe that's not the best way to do this. Okay, x plus y equal to 1. And you know what y is? Just put that in there. 2x plus 4 plus 1, which is 5, equal to 0. So x equal to negative 5 upon 2. Is that correct? I think it is. So you know what x is? What is y? Y is just negative 5 upon 2 plus 4, which is 8 minus 5 upon 3 upon 2. So negative 5 upon 2 comma 3 upon 2. This point, this is what we want. All right, cool. Next, prove that. What was I doing once again? 11th, I think. Prove that the point. Okay, these points are the vertices of a right angle triangle. Let's try to graph this. What's this? Question number 11. So if we try to graph this, 12 comma 8 somewhere over here, negative 2 comma 6 somewhere over here, I guess, and 6 comma 0. So this, the biggest side, it looks like this thing is the biggest side, so this should be 90 degrees. What is this point? This point is negative 2 comma 6. No, it's 6 comma 0. And this thing is 12 comma 8. And this guy, it is negative 2 comma 6. So what is what's these two slopes? 8 upon 6. No, 8 upon 12 minus 6, which is 8 upon 6. So like this thing is 4/3. And this guy, it is, what's it? 2 comma 6, right? It's not 2 comma 1. 6 upon negative 8, which is negative 3/4. Yes, so these multiply to negative 1. These are perpendicular. Got it. Next, prove that, oh, that's done. 12. If the, we don't want these. Uh, if the line segments joining the points A, comma B and C, comma D, okay, subtend an angle theta at the origin and find cosine theta. Cosine theta. Maybe we can do this using, I don't know, like, where is it? Sorry. We could use cosine law for this, but then maybe that's too complicated. So we'll just use slopes. Question number 12. So maybe this thing is A, comma B, and this thing is C, comma D. Right? What is this guy's slope? This is D upon C tan alpha, for example. And let's say this complete thing is beta, and this angle will be theta, right? So theta is beta minus alpha. Applying tan on both sides, tan theta is tan of beta minus alpha, which is tan beta, which is m2, minus tan alpha, which is m1 upon 1 plus m1 m2. And m2 is b upon a, so it's like b upon a minus c upon d upon 1 plus bc upon ad. Is that correct? I think yes. So yeah, it's just bb minus ac. Yeah, this is incredibly laggy. I don't think that shows the correct thing to write on. But you got what tan theta is. Now you need to find cosine theta, which isn't that bad. So what is sec theta? Sec theta is the square root of 1 plus tan square theta. So it's square root of 1 plus, what's this guy squared? It's just b squared d squared plus a squared c squared minus 2abcd upon a squared d squared. Okay, plus b squared c squared plus 2abcd. And this will be square root of a squared d squared plus b squared c squared plus b squared d squared plus a squared c squared upon, well, this guy we already know is just ad plus bc squared. And look at it, we can factor out some stuff, I think. So d square is common, and that will be a square plus b square, and what here c square is common, that's also a square plus b square. That's really nice. So it's just square root of a square plus b square. And then what's the remaining stuff? It should be c square plus d square by symmetry, right? But it is, of course. We don't even need symmetry for that. And denominator is just ad plus bc. So this is it. This is the answer. This is getting incredibly laggy. Okay. What was I doing? Right, question number 12. Now question number 13. Yes, question number 13. If alpha, beta, gamma are the real roots of this equation and the centroid of the triangle whose vertices are this. Okay. Real roots of this equation, centroid of triangles. Fine. So what's the centroid of triangle? It's just alpha plus beta plus gamma upon 3, and then 1 upon alpha plus 1 upon beta plus 1 upon gamma. That can be written as summation of alpha beta upon alpha beta gamma. But of course 3, because need that centroid formula. Okay, and what you know that summation of alpha, that thing is 3p, and summation of alpha beta, that's 3q. Then in alpha beta gamma, that's negative 1, which is 1. Putting that into this, you just get p comma q. There we go. That is the centroid. In a triangle, vertices are given, and oh, what is this? Okay, all the angles are given. Ordinate of the circumcenter of the triangle. Okay, this is bad. Try to graph this maybe. 1 comma 2, that's somewhere over there. 2 comma 3. And 3 comma 1. Hey, what's these slopes though? I mean, I'm just making a guess that it would be 90 degree, but what are these slopes? It's 1 and what's this? 1 comma 2 and 3 comma 1. Okay, that doesn't work. Yeah, unfortunately, it doesn't work. Ah, come on. It would have been fun if it did work. Okay, fine. What about C? C has 3 minus 1 is like, okay, 2, that 2 upon -1, that's -2 over there. And that's -1 upon 2. Okay, that's all it is. That, okay, I got it. That's all that is given to us. Fine. So you've been given that angle C. This is what? This is A, this thing is B, this thing is C. So this is an isosceles triangle, of course. Oh, you already got that this is going to be y equal to -x, right? I mean, parallel to that. And since C is 3 comma 1, this will be y minus 1 upon x minus 3 equal to -1. Is this really relevant? I don't know. You've been given what angle C is, what angle B and A are. And then the ordinate of this, she basically finds circumcenter like that. Okay. Now I wonder, why did they give us angles if they already have given us these coordinates, right? Coordinates themselves should be enough to just solve this. I mean, it's an isosceles triangle, so you already know that this guy is one of these perpendicular bisectors. You just need to find another. That should be easy. Okay, so what's the midpoint of BC? That's just 5 upon 2 and 4 upon 2, which is 2. Okay, and you know what? Okay, let's find the perpendicular bisector. BC has slope 2 upon -1, which is -2. So this slope, it should be 1 upon 2. So it's y minus 2 upon x minus 5 upon 2 equal to -1 upon 2. Man, this is really laggy. So 2y minus, it's y minus 2. 2y minus 4 equal to -x plus 5 upon 2. That's what this line is, but you already have got this line, which is y minus 1 equal to -x. Why is this so laggy? Plus 3. So if I subtract these, it's y minus 3 equal to 5 by 2 minus 3, which is it's just 2.5 minus 3, which is -0.5. So y is 3 minus 0.5, which is 2.5. Well, there we go. This was nice, I guess. So now you know what y is. It's just 5 by 2. From that, you can figure out what x is. X is what's 2? No, wait, it's 4. 4 minus y. So 4 minus 2.5, that is 1.5. So this will be 3 by 2 comma 5 by 2, I think. That is our point. Cool. And let's go to the next question, which is, if the coordinates of the midpoints of the sides of a triangle are 0, 0, 3, a and 0, 4, then the coordinates of the incenter are. Midpoints of a side, coordinates. Okay. Coordinates of incenter. Sorry. What was I doing? So you know the midpoint coordinates. So you know what the, wait a second though, how does, how do these midpoints give us anything about the incenter though? You know nothing about the actual triangle. You only know about the median triangle. Median triangle is somehow related to incenter. How? Maybe it's somehow related to similarity of, yeah, that could be a thing. Coordinates of the incenter are, no idea how this works. Oh, come on, think of it. Think of it. Is it that bad? Actually, no, you can kind of figure out what, yeah, because you know what the midpoints are. You can figure out the whole original triangle and then figure out what the actual incenter is. Uh, yeah. Let's try to do this thing. Let's try to do this. So it's 15th. What's the centroid? Centroid is 1 comma 4 by 3, I think. Okay, 1 comma 4 by 3 you say. So x1 plus x2 plus x3, that thing is 3, and y1 plus y2 plus y3 is 4 upon 3 times 3 is 4. And what was I doing? Yeah, x1 plus x2, that is, so let's just say that this guy 0 comma 0 is the midpoint of a and b, where a is x1 x2, b is x, sorry, a is x1 y1, b is x2 y2 stuff. So x1 plus x2 is 0, y1 plus y2 is 0. That's only, oh, that's weird. That means x3 y3, it's just 3 comma 4. So one of these is 3 comma 4. That's reassuring. Similarly, you can deal with everything else. So what was it once again? X2 plus x3, that will be the next point, which is, so 6, right? And y2 plus y3, y2 plus y3, what's that doing? That's 0 once again. Okay, that's fine. Putting that into that, you just get x1 y1, which is negative 3 comma 4. Yes. Okay, and now for the third point, you have, well, in fact, you don't even need a third point. We already got what x1 y1 and x2 y2 are. Just put that into this. So 3 minus 3 is 0. So x3 should be 3 as well. Okay, and what's this? 4 plus 4, 8. That goes over there, minus 4. You got the points. So what's it like? It's 3 comma 4 like this. That's the first point. Then you got negative 3 comma 4 and 3 comma negative 4 like this. This thing is 6, this thing is 8 and stuff. You know the incenter. Yeah, this is not bad. This is definitely not bad. This is like 5 and that's also 5. This is the midpoint, not the incenter. If we draw the triangle, if we draw the circle like this, this is R, this is also R. Our first thing is just find what R is. Like this is also R, of course. So how do you do that? This complete thing will be 10. 10 plus 2R, because 10 can be split into this plus this, and then that plus these two R's. That's the sum of this side and this side. That's 14. So 2r is 4, r is 2. Cool. Once you got that, you know what this point is going to be. This was just what? Like this was 3 comma 4, I think. And this is 2 comma 2. So like, okay, I mean minus 2, add to that. It is 1 comma 2. We got it. Okay. Question number 16. The medians of a triangle meet at 0, negative 3 and its two vertices are. The medians of a triangle meet at some point, two vertices are given. Its third vertex is. So medians of triangle meet at that. It's just the centroid, basically. So 3 times of that is like 0 and negative 9. So negative 1 plus 5, that's 4. 4 plus x equal to 0. X equal to negative 4. And 2 plus 4 is 6. 6 plus y is negative 9. So y is negative 15. There we go. You got this thing. Wait. Sorry. Third vertex. It's this vertex. What's this? It's question number 16. Okay, 17. The orthocenter of a triangle ABC is B and circumcenter is S. If A is the origin. Oh, this is nice. A is the origin. Rarely do I get these kind of questions where one of them is already the origin. What was they saying? Orthocenter of ABC is B. Wait, but B is also vertex. Oh, that makes sense. Like this could be the thing. It's B over here, and this is also the orthocenter. That means it's 90-degree with it. Next, they tell that circumcenter S is 0 comma B. Sorry, it's A comma B. Then the coordinates of C are. Where is the circumcenter really? Now it's a right angle triangle. That means the circumcenter is just the midpoint of this side. This is C. This is bad. This is C. And this point is A comma B, which is the midpoint. And that means C must be 2A comma 2B. Okay, cool. So that it is 2A comma 2B. That is our C value. Okay, what else? Any more questions? No, it's just that. Let's try to do this. So, oh, that's a bunch of colors. What is this color? Let's see what this does. So this is correct. Wow, this really is weird. What was I doing? Why is this line of okay? I don't know. Why did I make this? So 17 it's that, and 16 is negative 4, negative 15. That's correct. Then it should be 1 comma 2. Yes, that's correct. Then okay, this is all just calculation. Then 3 by 2 comma 5 by 2. Where is it? Wait, what? It's 14. It's 11.6. What is 14? Oh, I just want the ordinate. But isn't this that's a, it's 11/6 of all things. Why? Yeah, it makes no sense. Now where did we go wrong? Negative x plus 3, everything goes correctly. Y minus 3 equal to negative 0.5, so y is 2.5. That's it. Y should be 5/2. I don't get why this is correct. I mean incorrect. Angle A, angle B are equal. That means AB is the other side and AC and BC are the same. So the midpoint of AB, that's also the feet of perpendicular from C. So yeah, you just want the coordinates of the, wait. Where, what was this question? Circumcenter of the triangle. Huh. So this cannot be wrong. Maybe I don't know. Move on. This is incorrect. And then you have P comma Q. Yeah, that's correct. Okay. Then this value. Oh, this is sec alpha. So cosine alpha should be reciprocal of that, of course. So yes, it is correct. Sec theta, the same thing. Then you got 11th. No 11th because it's a proof, I think. That's cool. It's correct. Mm-hmm. Okay. Then what? Then 7 plus 3 comma 2. That's also correct. 3 is to 4. Hey, that's nice. Okay. Mm-hmm. 3 and 2. Okay, so the only thing where we went wrong is this 14th question, right? Okay, just erase everything and let's try again for 14th. Maybe this will work. How do I delete this? Oh, you can just delete it like that. Yeah, just delete it, man. Why is this not? I think it got hanged. Oh, it's gone. Why is this so laggy of all this? Um, okay. Okay, I don't want. How do I deselect this? Oh, this is how it should be. Why isn't this working? Why is this not working? Hey, come on, get selected. Okay, let's just leave this. What do you want? Want to do question number 14 with this colorful ink? So you have been given ABC and the order, and you'll know that angle B and angle A are all equal. That means C is, just one second, just angle A. Okay, this is annoying. This ink is very annoying. I'm just gonna choose black. A and what? Angle A and angle B are equal. That means these two lengths must be equal. This is angle C. Okay, cool. And ordinate of the circumcenter of the triangle. So the perpendicular bisector of this guy. Let's just find this midpoint and connect it like that. What is the midpoint of A and B? Oh, it's 3 by 2 and 5 by 2. This is incredibly laggy. Okay, so you know what this midpoint is, and what was C? C was, this question 14 is this thing. It's 3 comma 1. Okay, it's time to move on to something bigger. Then find out what this line is. Y minus 1. Why is this? X minus 3. Oh god. 2.5 minus 1 is 1.5. 1.5 minus 3 is negative 1.5. Why? Why is this so laggy? This is negative 1. Okay. That means y plus x minus 4 equal to 0. That's it. I can't bear it anymore. It's just getting very, very laggy. It must be something that I can do, right? Let's go home. Oh, good. Let's continue. Where were we? This was A, B, C. This point was A and B. It was 3 upon 2 and 5 upon 2. Our C value is 3 comma 1 was y minus 1 upon x minus 3 equal to 2.5 minus 1, which is 1.5 upon 1.5 minus 3, which is negative 1 upon 1.5, which is negative 1. So y plus x minus 4 equal to 0. That's the equation. That's this line's equation, and you also need that. So AC, what that midpoint is, A is 1 comma 2, C is 3 comma 1. So this will be 4 upon 2 is 2, and 3. So 3 upon 2 is 3 upon 2. And what's the slope? This slope is 1 upon 1 minus 3, which is negative 2, I think. So it's negative 1 upon 2. This slope should be 2. That means 2y minus 3 equal to 4x, because 2 times 2x, and then 4 times negative 2, which is negative 8. Okay, this is getting lengthy. This goes over there, this becomes negative 5. But you know that y is 4 minus x. Put that into this thing, so it should be 8 minus 2x equal to 4x minus 5. So 6x equal to 13. Oh, this is once again going very weird. It's 13 upon 6. Then what is y? It's just 4 minus x. So it's so it's like 24. 24 minus 13 is, oh yes, that's 11. That's 11. It's 11 upon 6, as they expected us to write. So now this is correct. So that's it. I will see you guys in the next video, because it's already too long now.